Uh, so today we're going to do curvilinear motion, which is basically motion in the x, y, z direction. Um, the learning outcomes for this class are to be able to express the position, velocity, and acceleration in 3 dimensions. Let's start. So I'm going to use a different notation for vectors. So the book uses a bold letter for vector. I'm going to use something like this. Okay, so I'm going to show an arrow over the alphabet in order to represent vectors. This is because it's very hard for me to draw bold with a pen. So this would be a vector, okay, and a scalar would be like this. So a scalar has only a magnitude, a number, but a vector has a magnitude as well as a direction. Okay, so in this class we're going to talk about position in 3 dimensions. So position is R, and that has 3 components: the X component, the Y component, and the Z component. Now, I also wrote down I, J, K. These things are vectors. They are vectors of unit magnitude. Unit magnitude vectors in X, Y, Z direction. Okay, and I'll use a hat to denote a unit vector. Okay, so an arrow to represent a general vector and a hat to represent a unit vector. And X, Y, Z are position of the particle in X, Y, Z direction. Is that clear? So once we have the vector, we can then find the magnitude and the direction of the vector. So the magnitude of the vector, I'm going to denote it by this thing. So R with an arrow is the vector, and the magnitude sign denotes the 2 vertical lines there denote the magnitude. And to find the magnitude, what you need to do is you need to take the X, Y, Z component and take the squares and add them up, and then take the square root of the sum. Okay. So the magnitude is always a scalar, a number. It does not have a direction, unlike a vector. The second thing, yeah.
Just a quick question. For the position vector, is that an R or an E?
Oh, it's an R. How can I make it more clear? Perhaps. Okay. Yeah, we'll use V for velocity and not for position. So the other thing is the direction of R, and that would be R hat, just like the unit vector I, J, K. R hat denotes a unit vector along R, and to find R, what you need to do is R with the hat. It's simply the vector R divided by the magnitude of R. So R is xi plus yj plus zk divided by x square plus y square plus z square. Okay, so this is, I believe you've seen all these things before. Nothing is new. Okay, just like there is, you can express the position as a vector, you can do the same things for velocity and acceleration. Acceleration and velocity are, in general, vector. They have a magnitude as well as a direction. So I'm going to just write these things down. Velocity. So V is, it's the rate of change of position. So what I need to do is, I need to do dr dt, and that's going to be x dot I plus y dot j plus z dot k. The magnitude is given by this. That is going to be the magnitude of dr dt, and that's simply the square root of x dot square plus y dot square plus z dot square. And finally, a unit vector is denoted by v, the vector v divided by the magnitude of v, and that is x dot I plus y dot j plus z dot k divided by x dot square plus y dot square plus z dot square. Again, the same thing for acceleration. Acceleration is a, and to find the acceleration, what I'll do is I'll take the second derivative of the position. So that's x double dot I plus y double dot j plus z double dot k. The magnitude is d square r dt square. That's square root of x double dot square plus y double dot square plus z double dot square. And finally, the unit vector in the direction of A is x double dot I plus y double dot j plus z double dot k divided by x double dot square plus y double dot square plus z square. Okay. Any questions on this? Let's take a bunch of people.
Get some water and come back.
Okay, let's move on. Okay, so here is a very basic question on what we have covered so far. And I want you to try to solve this. This is really applying the formulas I just wrote down. The position of a particle as a function of time is given by 2t comma 3. The 2t denotes that the x position is 2t and the y position is 3. You're going to write the position as a vector, write the velocity as a vector, and then find the velocity at time t equals 1 second. Can you do this problem? I didn't get that. Zoom in. Sure. Is it better? More? Okay, so what's the position? So position is r. So what's that? 2, 2, then what? 2t, 2t plus, oh sorry, 2t I plus 3j. Okay, now there is no z component, so it's okay if you don't write z, but really there's a 0 times k. Okay, so the velocity is the rate of change of position. So what you need to do is you need to take the derivative of the position, which is right here. So when you take the derivative, it's the chain rule. So there are two things here, right? 2t and there's I, but the vector I does not change with time, right? It's along the x-axis. This is a unit vector along I, unit vector along j, and so this particle is somewhere on this 2t3. So this I does not change, so we only need to take the derivative of this thing. So this is going to be 2 I, right? And then what's the derivative of 3? It's 0. So that's the answer. It's just 2I. And what's the velocity at time t equals 1 second? So what you need to do is you need to take this expression and put time t equals 1, but there's no time t there, which means that the velocity is constant too. So my bad, this should not be the magnitude. So it's 2I. Okay, so this particle is traveling along the x direction with a uniform velocity of 2 meters per second. Oh, I did not give you the units. So it's 2 in some units. Okay, it's traveling that way. It doesn't move in the y direction. Okay, is that clear? Okay, let's do some.
You're truly right. I don't know if this is what you use for your notes on Blackboard.
Okay, thanks. Anything else? Okay, so let's do some harder problems. Okay, so a particle is at rest and located at 3, 2, 5, and this distance is in feet. You're given the acceleration. A is 60I plus 12t squared k feet per second square. You're going to find the position of the particle, x, y, z, so the x, y, and z component at time t equals 1 second. Okay, so let's see, we're given A is 60i. Now I would write this down so that you do not get confused. You always, since there's the j is missing, I always write 0j plus 12t square k. And the only reason I do that is because if you just look at one by one, you might be misled into thinking that 12t squared is along j. This way it's much cleaner. So you're given A, and you're told to find the particle's position. So R is unknown. Okay, so in order to find R, and you're given A, you need to find the relation between A and R. It turns out that velocity is the integral of acceleration and position is the integral of velocity. So you can then use that. So what we'll do is first, so our strategy is to find V first, and then R. Okay, so dv dt is A, and that is 60i plus 0j plus 12t squared k. Now you could do it one element, one coordinate at a time. So you could take this and integrate it, take that, integrate it. But let's just do it in one shot. So I'm just going to do the integral over the vector. Okay, but that doesn't mean you cannot do it individually. So V is would this be confusing? Let me just do it the usual way. So I think this might be confusing if I write it that way. So I'm going to write this as x double dot I plus y double dot j plus z double dot k, where I need to find what x, y, z is. So when I say R is unknown, I need to find xi plus yj plus zk. I need to find x, y, and z. So the second derivative of R is x double dot I plus y double dot j plus z double dot k. So what I do is I compare x double dot with 60 because they are the x components, and then integrate it twice. So this is dx dot dt equals 60. So dx dot equals 60 dt. Sorry, this should be 60 dt, and then integral goes from what's the question? Determine the particle's position at time t equals 1 second. So I need to go from 0 to 1 for time, and the velocity is going to go from 0 to x dot. Okay, I could have written vx instead of x dot, but let me just write x dot. So this is going to be x dot, upper limit is x dot, lower limit is 0, equals 6t squared divided by 2. Hold on, my bad. I need to do a general integral. So then first I find the velocity as a function of time, and once I get the velocity as a function of time, then I would eventually put the value of t, which is 1 second. So this is t0, and note that the velocity is x dot at time t, and the velocity is 0 at time t is 0. That's why those limits are, they're not random limits. So x dot equals 3t squared. Okay, and then that is dx dt equals 3t squared. So what I'm going to do is integrate from 0 all the way to x, and time from 0 to t. So at x equals 0, the position is 0. Sorry, at time t equals 0, position is 0, and time t equals t, the position is x. So this is x equals 3t cubed divided by 3t0, and so x equals t cubed. Okay, is that clear? Okay, you guys did not catch me. I did a mistake. What mistake I did? Read the question. I'm not satisfying the initial condition. So you're told that the particle at rest is, so it is at rest, so velocity is 0 at time t equals 0, but the position is not 0. It's 3, 2, 5. So you guys should catch me if I did a mistake. So this is not 0. This thing here. This is not 0. It is 3. Okay, so this will change to x minus 3, and so this thing will be x equals t cubed plus 3. Okay, so that's just the position, the x position. You got to do the same thing for y. Y double dot is right here, it's 0, right? So I'll write 0. And then you got to do the same thing for z. So z double dot is, what's z double dot? It's equal to 12t squared, right? So carry out the integration twice. You know the velocity at time t0, you know the position at time t0, and you can solve for x and y. So I'm not going to do this. I want you to try it at home. What you should end up is y equals 2 and z equals t raised to 4 plus 5. So you're asked to find x, y, z at time t equals 1 second. So you need to put time t equals 1 here. So at time t equals 1, x position is 3 plus 1 cubed. So that's 4. The x component, the y component is just 2, and then z component is 1 raised to 4 plus 5. That's going to be 6. So that's the answer. So I gave you the answer. I gave you x, y, and z. I want you to fill the dots. Solve for y and z. Do it at home. Okay, any questions? No questions? Zoom it. Okay, so a particle travels along the path defined by a parabola, y equals 0.5x squared. Okay. A parabola looks something like this. So for every value of y, there's 2 values of x, so it should look like this. So the particle moves along a parabola. So you're given the x component of the velocity, that's 5 times t. You want to find the distance the particle travels from the origin, so it starts. This is the origin. You want to find the distance the particle covers from the origin till the time is 1 second, and then you need to find the magnitude of the acceleration. Okay, you're also given that at time t equals 0, the position is, so this is basically where the particle is. This is at t equals 0. Okay, so it's somewhere, and I guess here, randomly drawing a point, you need to find where that point is, and also the acceleration at time t equals 1. So again, it's the same application of the same formula. You know the acceleration, or if you can find the acceleration, then you can, well, you're told the velocity. So if you know the velocity, then you can find the position by integrating, right? So let's see. So you're given that x dot is 5t and y equals 0.5x square, right? So if you can find v, okay, I'm not writing the z because this is a planar motion in the xy plane. If you can find v, then you can integrate v to get x, and that's the first question. So v is x dot I plus y dot j. We know what x dot is, it's 5 times t. We don't know what y dot is, so let's try to find y dot. So y dot is the derivative of 0.5 x square. The derivative of x square is 2 times x, but then this is not just the derivative with respect to x, but it is the derivative with respect to time. So I also need to take the derivative of x, which is x dot. So this is x dot. So x is you're not given x, okay, so I'll write it as it is, and x dot is 5 times t. So 5 times t times x. Okay, now x is unknown. You know the time, t is 1 second, but you got to find x. Yeah, question? I can't. Can you say that again? 0.5x squared. Are you talking about this? It's 0.5x squared, yeah. 0.5x squared. Okay, so we don't know x, so we better solve for x before we can solve for y. Okay, so we are stuck because we don't know what x is. So what I'm going to do is I'm going to try to solve for x first, which is right here, right? Which we know it's 5t, and then sub that in here for y dot, and then solve for y. So x dot is 5t. So dx dt is 5t, and so dx x 0. I write x in 0 because at time t equals 0, the particle is at the origin. So 0 to t. Okay. So this gives me x equals